Hello everyone. So in this video, I am going to explain about today Codeforces round question. So G good key or bad key. So in this question, there are n chests. The ith chest contain A coins. You need to open all n chests in order from chest 1 to chest n. So there are two keys you have. One is good key, which costs k coins to use, and another key is bad key, which does not cost any coins, but it will reduce the coins which are present in upcoming chest by 2. So it will reduce the coins by 2, divide this coins by 2. It is a round down operation. It means if the 5 coins are present, it will reduce it to 2, because the 5 will be divided by 2, so it will be round, it will be floor, it will do floor division. Um, if any key one time if we use the key, it will be break down, we cannot use again. So you need to use the in total n keys. So we, for each chest, initially you have no coins and no keys. If you want to use a good key, then you need to buy it. During the process, you are allowed to go into debt. For example, if you have 1 coin, you are allowed to buy a good key worth 3 coins, and your balance will become negative coins. Okay, so you can, so this is the question. So you have n chests. You want to open with any one of the two keys. One is good key, which costs k coins. Another one is bad key, which will reduce the upcoming chest coins by divide the coins by 2. So we want to find the maximum number of coins we can get by opening the n chests. So this is one of the DP type problem. So you can solve this problem using dynamic programming and greedy approach. You can this dynamic programming nearly is a prefix sum. It is also similar to prefix sum problem. So I will explain how we can solve this in algorithm section. So now move on. So now I take the first example. There are 4 elements, 10, 10 and 3 and 1. So these are the chest coins which are present in the particular chest, and the good key value is 5, which is given in the question. So now I want to find the maximum number of coins. So how we can solve this by dynamic programming? So we will find all possible ways. Okay, for example, if I choose the bad key from this state, so what is the cost will be that? So the cost will be the summation of, so if I choose for this particular position, the cost will be, it will be divided by 2, and this will be divided by 4, and this will be divided by 8. Okay, so which means the cost will be depending upon the, okay, so how much coins I will loss if I choose the bad key. So if I choose as a bad key, the loss is depending upon the previous values also. So you can see this will lead us to the prefix sum concept. Okay, so I will explain that. So now I will choose. So if I choose the bad key from this position, so my loss will be 1 minus 1 by 2. Okay, so my current value, current coins is 1. So my next upcoming my coins will become 1 by 2. So my loss is 1 minus 1 by 2 will be 1. So again my current chest coins will be now 0. My chest to become 0 in this position. So again if I do any operation, so the loss will be again 0, because my coins will become 0. So 0 minus 0 divided by 2 will be 0. So again it will be 0. So for each state I want to do prefix sum. So I will do addition operation with previous state. So I will create the previous state. This is the edge. It is created. It's an empty previous state. It's created to avoid checking edge cases. So I will do sum with this previous element. So 1 plus 0 it will be 1. Okay, the same way. So no change will be happen. Again there is a 3. The next element is 3. So if I choose the particular in this position, if I choose the bad key, so my loss will become 3 minus 3 by 2. Okay, this will become 3 minus 3 by 2 will become 2. Okay, 3 minus 3 by 2 will give us my loss will become 2. My current value become 1. Okay, again I will do this 1 minus 1 by 2. My loss will be become 1. The next step it will become loss becomes 0 and 0 and 0. So it will go up to, we will store this state up to 30, because it will be the maximum integer size in the constraint. In the constraint, the integer will become 10 power 9 only, so it is become up to 2 power 13. So you can see it is a log, it is will reduce like a log value, so it is log 2 value. So the total space we require is maximum space is 30, so I will do fill this value up to 30. So next is 10. So if I choose this position as bad key, so 10 minus 10 divided by 2, so it will become 5. Okay, so my loss will become 5. Again, if I choose the bad key, my loss will become 5 minus 5 by 2. So my loss will become 3. Again, if I choose this uh, a bad key, so my current element is 2. 2 minus 2 divided by 2, my loss will become 1. So again, if I choose this as a bad key, again my loss will become 1, and finally it will become 0. So you can see I will do prefix sum operation, forgot to do that. So if I do 2 plus 1 will become 3. So 1 plus 0 will become 1 only, and 0 is 0. Again, if I do prefix sum, it will become 8. Okay, it will become 4. It will become 1 only. Again, it will become 1. So again 0. So the same way it will also will be filled with 5. So 5 plus 8 will become 13. So that next is 3. So 3 plus 4 will become 7, and 1 plus 1 become 2. So again 1 plus 1 become 2. Again 0 plus 0 is 0. So from this state, what you can find out that, so this element will tell if I choose this, if I choose the bad key from this position. Okay, first bad key from this position, this is the cost. Okay, so this element will tell if I choose the first bad key from this position. So this element will be say if I choose the third time as a bad key, it will be the cost of, it will my loss is become this much amount. So this DP table will tell in which time I will take the bad key. So if I take the bad key at particular time, so it will give the loss of my coins. Okay, if I choose the fourth time bad key at this position, it will it will lost my 2 coins. Okay, so this is the concept. So after building this DP, the main algorithm is started. So may I have 2 choices. So if I choose one, may I choose good key or I can choose bad key. Okay, for this position, if I choose good key previously, so my previous good key will be 0. Okay, and next may I can choose for other elements, may I can choose for bad keys. So if I choose from this bad keys, so my cost will be, so this is the first bad key. If I choose, so the cost will become the summation of this value. So the summation of this value is 13. Okay, 13 plus. So next again, if I move this, so my bad key value is 4. So 4. So you can see this is the greedy approach, because maybe it have proofs. Maybe try to prove that, because if I choose one time I choose the bad key, my upcoming will be also become the because if I choose bad key is my best option, then upcoming chests also will be opened with bad key is the best option, because you can see, because it will be reduced by more quickly. The good key value will be take be constant, but the bad key value, if I this is will be the best option, then my good key, then the upcoming options will also will be good option for bad keys. Okay, so one is I can choose good keys for previous elements. Uh, Previous elements. In upcoming elements, I will try to choose the bad keys. If I choose the bad keys from this position, my cost will be 13 plus 4 plus 0, the diagonal way. Okay, 0. Again, it will become 0. Okay. So my previous value is 0. If I choose the bad keys from this state, my sum is 17. So 0 plus 17 will become 17. This is the one of the possible answer if I choose choose bad keys from this position. If I start choosing bad keys from this position, so previous this state I will choose the good keys. So good key value will be 5 plus, and the bad key value become, so from this state I will choose the bad keys. So in this state the bad key value is 8. I did not write very clearly, so please try to please adjust that. And the bad key values from this position, this diagonal is 1 and 0. So this will be lead us 5 plus 8. 5 plus 8 is 13. 13 plus 1 is 14. Okay, this will become 14. So this is one of the possible answer. Next, if I start choosing bad keys from this position, so if I start using bad keys from this position, my good keys will be, I will use two good keys, so it will be cost 10 plus, I started from this position, so it will be 3 plus 0. So it will become 13. Okay, and the next option is, if I choose bad keys from this position, okay, if I choose bad keys from this position, so my good keys, I use 3 good keys, so 15 plus 1 bad key, so equal to 16. So this is the minimum loss I can get by choosing this order of keys. So what is my profit is, so 10 plus 10 is 20, so 24. So this is my total profit if I open without any loss. So my loss now become 13. So my net profit is now is 11. So this is the answer which I can get the profit, maximum profit. So I hope you understand this. So for the so I try to choose good keys as soon as if I choose bad keys from particular position, okay, I try to choose good keys. So I'll check from, if I choose bad keys from this position, which is lead to which answer. Okay, if I choose good key until good keys, and this will become bad keys. So this is one of the way. And next operation I'll increase my good keys and reduce my bad keys. So in the state which is my option, so I try to find all the ways, and finally I choose the minimum one, and this is my minimum loss. I finally subtract with my total total coins present in the chest, and subtract with total coins with my current loss. So this will become the answer. I hope you understand. So I move on to the coding section. So in this coding section, I first take the input and I create a DP array. So with 32 rows, it's 30 rows only enough. So I created extra rows. And next is I will create n plus 1 columns. So this extra columns for edge condition. And if I iterate from the end of the array, because I want to find the postfix. Okay, postfix DP. So I from the last. So I will calculate the last. Okay, if I choose this as a bad key, so I will find the last and add this last with the previous state. Okay, this will become the new state. Okay, I will reduce my current chest coins by 2. So I will repeat this process for all chests, and also find the total coins present in the chest. And the next operation I will try to find the minimum cost. Okay, minimum last cost. So I will iterate from the first element. So my bad sum equal to initially is 0 and good sum equal to initially also 0. So I will find the bad sum if I choose the this element. Okay, if I choose this element from this element, I will choose the bad key. So what is will become my bad key sum? So I will start from this. Okay, start from ith index to n index, and also there is only 30 elements will be present in 30 rows will be there. So I will iterate from the 0th row to 30 row. So it will move in diagonal fashion. What I explained in algorithm section. So I will find the bad sums value, and finally I will check last cost which is minimum of already last cost and or my good sum plus bad sum. Okay, In the next part, I will increase my good sum value with good key value. So finally, is another edge case, last case. I will check the minimum cost with my last cost or my good sum. So which means if I did not choose any bad keys, I only choose good keys. This also will be, I want to check this. So finally, I will print the answer, which is total cost minus last cost. So this is the concept for this problem. This problem look like a little hard, but try to draw a table, DB table by yourself and try to understand this problem. So you want to choose these values very greedily. So hope you all understand. If you have any doubt, please kindly mention in comment section. So we will meet on next question. Thank you.